Good afternoon, everyone. Welcome to a webinar this afternoon hosted by Onset. The title of today's webinar is Utilizing Data Loggers for Agricultural Research and Environmental Monitoring. My name is Ellie Snyder, and I'm going to be the main presenter today. And I'll be joined today by Paul Gannett, who is our Principal Product Manager for the question and answer session. So we'll go ahead and get started with today's webinar. And we will hold questions and answers for the end of the webinar. Okay, a little bit more about myself. I work here at Onset as a sales development manager with a focus on the higher education market. Within this, I work a lot with land-grant institutions and also agricultural producers. My primary product focus is in the HOBO connected products, which serve agricultural and environmental research applications. My background is actually in agronomy. I worked in agricultural research and extension in addition to agricultural production prior to joining Onset. I became familiar with Onset products because I actually utilized them in my extension work, serving apple growers in the region where I worked. Go over a few webinar logistics today. So the webinar today will last about 45 minutes. We'll save 15 minutes at the end to answer questions. You can enter your questions at any time in the questions box. There's an icon of that on the right side of the screen, and you should be able to pull that up and enter your questions there, but we will answer them all at the end. This is being recorded, and we will make it available to the attendees. We also have a number of webinars that are available on the Onset website. So a little introduction to Onset itself. Onset manufactures HOBO data loggers. So it's focused on creating accurate and reliable data logging and monitoring equipment. The company is located on Cape Cod in Massachusetts. Onset was founded in 1981 and is a world leader in data loggers with a global network of distributors. We do all of our manufacturing and engineering in-house, so these are made in USA products. Go over the agenda for today. First, we'll talk about some data logger basics. So what is a data logger? What are the components? We'll cover what to consider when selecting a data logger. We'll go over some of the HOBO data logger products. Today, we'll focus mostly on the outdoor and terrestrial line of products, but I'll briefly mention some of our outdoor and water products as well as indoor products. And we do have webinars on those, focusing on those products at other times. So if those are of interest to you, be sure to look out for notices about upcoming webinars that cover those products. And I'll cover some tips for planning your data logger design and deployment. Okay, so what is a data logger? Basically, there are two components to most of the products that are manufactured here as data loggers. There's a sensor, so the part of the product that actually measures something that you're trying to capture, and there's a part that stores that data and transfers it. For example, on the left, you'll see sort of a white box with cables connected to a soil moisture sensor and also a temperature sensor. So this is a combined soil moisture and temperature data logger. The white case with the button and says soil moisture and temperature, that's where the data is stored, and that also contains the transfer mechanism. Some of them, such as the blue HOBO pendant that you see, have internal sensors, so you may not see the sensor separately from the data logging piece of it. They may be housed in the same container. Some things that you need to consider when you're selecting a data logger. What do you want to measure is the most important. Are you trying to measure temperature, relative humidity, wind speed? Do you need to measure something in the water? Do you need to measure rainfall, soil moisture? There are many different things you could measure. So that's the most important and first thing you should think about. Next, consider where your data loggers will be deployed. So there are certain data loggers that are designed for indoor environments and applications and also outdoor applications. And as I mentioned earlier, there's some designed to be used in water and different levels of salinity within that as well. So that will lead you to a certain set of loggers that are specially designed to be utilized in those different environments. Something else to consider is data access. Is remote access to the data necessary? So do you need to be able to see the data if you're not on site where the data logger is present? It may not be practical to travel to the site to offload data. It's another consideration. So consider if that's practical, and if so, how frequently you could access that data or access the logger. Consider who needs access to the data and when. And then something else to consider is if the environment where you're deploying the data logger has some kind of connectivity, whether it be an internet service or a cellular service. So in the next section, I'm going to introduce some of our Hobo products that are suitable for outdoor and terrestrial applications. As I mentioned, I'll focus more today on agricultural applications and environmental applications, and we'll highlight some of the products that are utilized in those areas and also talk about how they function. So some examples of applications might be climate research, crop and livestock research are very popular, and then many of these products are also used in agricultural production. Some examples of applications in that realm are frost alarms or temperature monitoring, soil moisture and temperature metrics that can help just inform irrigation management decisions or planting times. Other applications include using the data to run disease and insect models to help predict infection events or an insect life cycle. So within the outdoor products, there's a few different series. There are some, and these differ based on how you offload the data. So the standalone products here are accessible with a USB offload. So you can deploy these alone, and then when you want to or need to access the data, you have to return to the logger and actually plug it in and access the data with the USB offload. The next column of products are mobile device products. So these are products where the data is accessed with a Bluetooth connection from a mobile device. And on the right, there's a series of cloud-connected products. So these products feed data to the cloud via a cellular connection. So going over some of the outdoor applications again, briefly touched on those, but weather and climate data is very popular use of these products. Many of the outdoor products are very rugged. They can withstand extreme temperatures and climate conditions. And so even if the data can't be accessed frequently due to lack of cellular connectivity in a certain area, these loggers will withstand those conditions and continue to collect data in extreme environments. In agricultural research, they might be used for collecting weather data at a research site or monitoring soil moisture conditions under various microclimate conditions or irrigation management protocols. They can also be used to help develop agricultural models. So having consistent weather data in a location that's easily accessed and validating models with that weather data is certainly a useful endeavor with these type of products. In production, agricultural producers are using these tools for again, temperature monitoring. Sometimes they might be used for frost alarms, alerting of a frost risk in a certain location, or it could be a high temperature situation, perhaps inside a greenhouse or a high tunnel. They might be used to monitor soil moisture for irrigation purposes. They can be used to help in site selection for a new planting of something. So monitoring microclimates, frost pockets in a new area, or monitoring soil moisture to assess the risk of soil-borne pathogens developing in a certain area can help producers decide if a site is appropriate for planting a specific crop. Tools are used to monitor light intensity and photosynthetically active radiation, so helping especially greenhouse growers or those modifying the environment to assess whether there's sufficient light for producing a crop or if there needs to be supplemental lighting in a certain situation. Light intensity can also be used in some crop production models. And as I mentioned before, the data from these outdoor loggers can be used in disease prediction with appropriate models, as well as insect life cycle tracking. And they can be fed into degree day models to help time management practices in different crops. So to go over a little bit more detail, some of the loggers that are available, and I'll group these by data offload. The outdoor USB loggers, these include an individual or a micro station. So this is a central data logger that can connect to many different sensors. And again, you would offload the data with the USB. There are also individual loggers that can be placed alone to monitor a specific area. And again, offload the data with a USB. You have to go to the site and physically collect the logger and offload the data that way. Some of these can be very low cost and very convenient. They're ideal for remote situations where real-time or remote access to data isn't necessary. These do require software, which is called HoboWare or HoboWare Pro, depending on the particular sensor that you're using. You might use one of these two softwares, and within that software, there's some different capabilities, such as a growing degree day model and other graphing and manipulation that you can explore with the data through that software. This is one of our lines of outdoor Bluetooth loggers, and these are again, they've got different sensors attached to them. Some have internal sensors and some have external sensors, and they again can be deployed individually like the standalone USB loggers, but you offload the data with a cellular device. So the MX2300 series, which is pictured across the top here, include an internal temperature and R rate and relative humidity sensor, one that does temperature and relative humidity but has an external sensor that's wired to the data logger, one that does two external temperature and RH sensors, so you could place the sensors in different locations if you wanted to measure, say, temperature at two different heights in a certain location. There's also soil moisture and temperature Bluetooth loggers. These tend to be ideal for test fields or greenhouses, perhaps monitoring temperatures in a smaller farm situation where you're visiting frequently. You can access that data with a mobile device every time you go by, check on the current conditions or offload data from the previous day, and help make decisions that way. This is ideal, again, for a remote location also, where you only need to go and access the data every so often. Again, not something where you want to have remote access to it. There are also other Bluetooth loggers. So we have tidbits. These are some of these can be deployed underwater and also in soil, and so they're sort of a lower cost solution for monitoring terrestrial situations. So again, these Bluetooth loggers are pretty easy to deploy, and you offload the data via a free app called HoboConnect. So you can download the app, and in that app, the app should recognize a Bluetooth logger that's within range, which is approximately 100 feet away from the logger. From the app, you can program the logging interval. You can also program the start and stop time of logging, and you can adjust the data storage settings. And then when you're ready to export the data, you can do that as a CSV, Excel, or .hoboware file if you're using the HoboWare software. Now I'm going to move on to the outdoor web-based loggers. These are data loggers that can connect to multiple sensors, and they have a cellular connection feature that provides automatic data offload and remote data access. So you can communicate with 5 to 50 sensors, depending on the model. These are ideal for crop monitoring, using data for predictive models, and for setting alarms that you want to receive remotely. There are a number of different sensors that can communicate with these data loggers. So there are wired sensors which plug into the actual loggers. They need to be deployed close to the actual logger. The cellular data feature of those of the central data loggers means that you can place them basically in a convenient location close to where you want to have these wired sensors measuring the environment. In other words, they're not restricted by having to have access to an internet connection, so Wi-Fi or Ethernet is not required. All you need is a cellular data plan. So the wired sensors include temperature, relative humidity, PAR, rainfall, wind speed, direction, soil moisture, solar radiation, leaf wetness, barometric pressure, pulse input, 420 milliamp input, and 0 to 24 VDC input. And there, the wireless sensors can do all of these as well, or most of these, except for a few differences on the bottom. There is a multi-depth soil moisture and temperature sensor available here. There's also a line of soil moisture and temperature, soil moisture, temperature, and EC, and then soil water potential sensors that are available as wireless. So how do these wireless sensors communicate back to the main data logger? Basically, the sensors are connected to one of these kind of white colored boxes. And inside of that has the data logger, and it also has the ability to send data back to the main central data logger station. And this is possible through a sub-gigahertz wireless mesh network. So it's communicating with this main data logger through that sub-gigahertz network. And it's a self-healing network. And so if one, they can communicate through each other, and then it's a self-healing network. So if one of these goes down, Another one can find a way through another sensor back to the main data logger, or it can go directly to it. These can communicate back to the main station through up to 5 hops, and they do repeat off of each other. There are also repeaters available to extend the range of the wireless capability. So again, these are the sensors that are available with that wireless capability, also known as HoboNet. Temperature and relative humidity, solar radiation, PAR, leaf wetness, pulse input, rainfall, wind speed and direction. We have an ultrasonic wind speed and direction, multi-depth soil moisture, and several other soil moisture wireless sensors. To access the data, you can use an online-based software interface called HoboLink. And you get access to this as well as storage, as well as your cellular connection by purchasing an annual data plan. So in HoboLink, you create login information, and you can set up your station at the time of deployment, entering serial numbers, and as soon as you're connected, as soon as you start the cellular connection, you will start to see these populate in HoboLink, and you can program them here. So when you log in, you can see information such as the last connection time, the strength of the connection of the HoboNet connection, so between the actual sensor and the data logger, battery strength, and you can see if there's anything of concern, or if the actual sensor is in alarm state. And you can program each sensor to send you an alarm or send you a notification if it, based on certain thresholds, if that's of interest. For example, low temperature, low soil moisture, high wind speed, etc. You can create customized dashboards that make it easier to visualize the data. So in the dashboard feature, you can choose what sensors you want to show here, and if you want them in graph form, or how you'd like to view them. You can also share this through a public link with public URL and post that somewhere if that's of interest. Or you can share that with others who just may have interest in seeing the data, other researchers, etc. There's also a mapping feature in HoboLink. So this is an example of what a HoboNet wireless deployment looks like. The central blue box that says Koonamasset, that is a central data logger, and you can see the different sensors that are placed around this farm. There's an icon that indicates the type of sensor, and then the latest reading will also show up in this mapping feature. You can also export data from HoboLink. So if you would like to download certain set of data from this that's been collected by a particular logger or sensor, or all of your loggers, you can do that, and it's very customizable. There's also one data feed that's available to set up through HoboLink. This can feed data to the Network for Environment and Weather Applications, which is a website hosted out of Cornell University. And the website has many different crop models. So on the right, you can see a list of some of the Apple models that are available for anyone to use on the NUA website. They take local weather station data, and then you can often pair that with some local observations and run a model to help you with disease, infection, event prediction, insect life cycle timing, crop management decisions. Apples are just one example of a crop that NUA has models for. There's also vegetable models, grape models, conifer models, corn models, and others. They do have a growing degree day model as well. on the NUA website. But you can also take that data and plug it into your own model if you have them not accessed through here. This is an interesting feature because in some situations, one farmer or one research station or one extension office will have a weather station that's feeding data to NUA, and many growers in the area can use it for different applications, even if they're not using, or even if they're not growing the same crops. You do have to have a certain set of sensors to feed data to NUA. But again, this is, you can also access the data, again, through specific queries that you may be interested in, depending on your research interests. So there's some important design and deployment considerations. It's good to be familiar with the terrain where you're going to be setting up your system to help you decide whether or not a HoboNet system is appropriate, or how many repeaters you may need, or where you're going to place sensors, etc. It's good to know the number and types of sensors required before you design a system. And in some cases, you may consider whether or not one system is sufficient. Again, HoboNet sensors can make up to 5 hops back to the main station. They should be communicating about 1,500 feet line of sight, or you could extend that a little bit if you raise the moat height. So as I mentioned before, I was going to focus on the terrestrial products, but I'll briefly mention some of the water products. Some of the common applications for the water products include monitoring water temperature, water level, and water quality. There are different data offload options for the water products. There are some where you manually offload with USB system. Others that you offload data with Bluetooth, and then there's some remote monitoring options as well. Some of the common metrics are water level, water temperature and light, dissolved oxygen, there's pH, and conductivity. And Hobo makes a line of indoor products. These are often used to monitor the indoor environment or air quality, energy use, and HVAC efficiency. So again, these loggers are designed to be used inside. There are several versions of standalone products for different metrics, as well as those that are Bluetooth enabled or mobile device connected products. One unique feature of the Bluetooth indoor products is that there is something called an MX gateway, and this actually collects data from the Bluetooth products that are within range and can feed them to the cloud with an internet connection. So the MX gateway is ideal for when there's multiple sensors being utilized inside, to avoid having to individually collect and offload data from many sensors that are within a small area. The HoboNet line can also be used inside. So that wireless mesh network of different sensors can be connected to a HoboNet station, and similar to the outdoor application, can monitor different areas within a certain range. So it's important to point out the water products and the indoor products, even though it's mostly talking about agricultural applications. Water certainly can be a concern if you're monitoring water quality in irrigation water or water level in a well or a pond. And then the indoor products might be of interest for storage facilities, for livestock housing, and so you know, these products are, while they're often used by different markets, they may be of interest in agricultural applications as well. Finally, some tips for planning your data logger purchase and deployment. Recommend obtaining product information and estimates before submitting grant proposals. Sometimes someone who's knowledgeable with the different products out there can help you select the best setup for your situation. And it's sometimes difficult to estimate, what the actual cost may be if you're not familiar with what all products are available and what would be best suited for your site. So I definitely recommend reaching out to Onset or Hobo or whatever data logger you're looking at and consulting with a sales representative in that grant application process. Something else might be to coordinate with others on a research project to promote consistency in your data collection and data logging. So if you have a multi-state project where you're monitoring the same thing across different locations, it's good to get on the same page and make sure you're collecting a compatible set of data that can give you sort of standardized information across different sites. If you're at a research site where there are multiple researchers doing different projects, you may coordinate with others to see what they may need in terms of data logging capability. Perhaps you can share equipment, share one of the HoboNet weather stations, save some resources by sharing that equipment, and also make that available for others to use in the future. And the last suggestion I have is to plan for flexibility and longevity of use. So if you are planning a data logging deployment for a research project that you have coming up soon, but you have different research goals long term, you may consider investing in a more robust setup in order to enable you to do your long-term research goals with the existing equipment. All right, and that wraps up the presentation for today. And now we'll open it up to questions. And Paul Gannett will join me for the question and answer session.
Hello, everyone. Glad to be joining you today to address some of your questions. I want to thank those of you who sent your questions in advance, and we'll probably start out with some of those questions first, and then we'll address some of the questions you've been sending in during the presentation. So let me bring up some advance, and I'll be asking the questions, and then between Ellie and I will be answering those. So the first couple of questions I had were in regards to costs. And it's a very legitimate question to get a sense for what kind of pricing we have, just to give you a sense. So the first one is, what are the most robust and cheap humidity and temperature data loggers and sensors to install in a field experiment? You want to throw out a couple options there, Ellie, or?
Yeah, field experiment with temperature and relative humidity. So a Bluetooth, again, the question here is sort of do you need remote access to data, or can you go off of the data with Bluetooth? Certainly some of the Bluetooth temperature relative humidity loggers would be appropriate, but then if you wanted remote access, you could consider one of the cellular cloud connected systems. Sort of depends on your setup. And if you're monitoring a number of different sites that are close to each other within range of that HoboNet network, then that might be a good option. But if they're far apart from each other and you just have one area that you're monitoring that's several miles from another, then perhaps the Bluetooth option would be better.
Yeah, just to add some specific dollars behind that, the Hobo MX 2300 series data loggers that Ellie mentioned earlier, the Temp RH model of that sells for under $200. It's $190 to give you a sense of very low starting point for those loggers, and it's the app, the Hobo Connect app for those is free. So that's a great entry point, and they're very robust, designed for field use. In terms of web-enabled stations, those start in the $1,200 price range, including a temperature sensor, just kind of your most basic system, with just a temperature sensor, and that includes a data plan, as well as the integrated cellular communications to get the data up to the internet. So that just gives you a little sense for, basic starting point for standalone and web-enabled stations. Another question, this one is a little bit more complicated, but we've got it is a fairly common question, is can the sensors be recalibrated when moving, and the follow-on to that is when moving sensors within the field, is recalibration necessary? And actually, Ellie, I think I might be better suited to answer this one, just because this is getting into a little bit more of the details, and I'm a little closer to that. And that is, the answer on recalibration really depends on the sensor. Many of our sensors hold their calibration for multiple years, and they don't need to be recalibrated, like temperature sensors. They're very stable over time, so they really don't need a recalibration. We do have the option in HoboLink, which is the web-enabled interface, that you can add an offset and multiplier to adjust your data if you do happen to notice that there's been a drift up or down in your temperature measurements, for example. So all of our sensors have that ability to be linearly adjusted to correct for any drift over time. And some of our sensors, like the rain gauge sensors, they have screw adjustments that allow you to adjust the calibration on those. So, that's just kind of gives you an overview of the sensor calibration. Obviously for specific sensors, we could that you're interested in, we can address those separately. Let's see. Here's another question we get. Data collection where there's 0 cell phone service, but we can do 900 megahertz radio links. We also have some Wi-Fi available. What do you suggest for that, Ellie?
I guess if you don't need sort of access to real-time data, then one of the USB stations could be appropriate. But currently we don't have a Wi-Fi enabled version of our RX stations. What would you add, Paul?
Yeah. A lot of our users are deploying our loggers in remote environments where they don't have cellular. So it is pretty common. You can use either our standalone loggers or our standalone stations, and offload the data either via USB or Bluetooth, depending upon the logger. So, that is a very common thing, because a lot of the climate change that's happening that people are studying is in remote environments such as the Arctic. So, that does mean you have to get out there. But the loggers are designed to last for a year off a single set of batteries or more, and that allows you to deploy them through the harsh winter season and go back and retrieve the data the next season if you can't get out there more frequently. Next question. Do you have a solution for measuring low-level inversions, possibly a 10-foot mast with a second temperature sensor? Want to talk about that one?
I'll let you talk to that one.
Okay, yeah. This is not as common a question, but it's pretty easy to set up a station with multiple temperature sensors. So, especially like in frost management applications, frost alarming applications, it's quite common to look for those inversions. And also in spraying applications, the inversions are important because that can sometimes trap some of the overspray at ground level and cause it to spread more. So, you just have to have a mast with the temperature sensors mounted at multiple levels, and you can have as many temperature sensors as you have input channels. So our typical stations will accept up to 15 temperature sensors, which is more than enough for temperature inversions. So yeah, no problem. Okay, the next one I have is, how can I share the map in HoboLink with the RX3000 sites to the public/farmers? Talk about that one, Ellie?
Yeah, so in HoboLink, you can create a public URL and then also customize what people see with that. So they can see the dashboard, or they can see the map with the current conditions, or they can see the actual list of different sensors and their latest readings. But they can't access the rest of HoboLink. In other words, they won't be able to go in and alter any of your settings or logging intervals or anything like that.
All right, thanks. So far, I'm going to switch gears now to some of the questions that have just come in during our session. So let me address some of those. I may have missed it, but what's the range of the mesh loggers and probes? Can you make sure you repeat that?
Yeah, so the range is generally 1,500 feet. So that should be line of sight. In other words, not really with major obstructions in between. They can travel through some canopy and foliage, and some obstructions, but like a major building in between might encourage the network to go around the building. And then if you place the modes a little bit higher up, so I think you said maybe above 6 feet, Paul, is that right? You can extend that range a little bit, maybe up to 2,000 feet. And again, they repeat to up to 5 hops back to the station. And there are repeaters. If you struggle with some connectivity between those, you can always add a repeater later on to a system.
All right, thanks. Next question, and actually I think I'm going to take this one because I'm just more familiar with this software. What is the easiest way to view real-time graphs of HoboConnect sensors, the ones with the Bluetooth communications? And there's actually a, you may have noticed it in the screen when Ellie showed it for the HoboConnect software. There's a live data viewing option when you're connected to the logger. So that's very handy when you're on the site and you just want to make sure you're talking to the right logger. You want to, make sure it's responding appropriately. You can view that data live while you're there at the logger. So good question. And here's a question just for clarification. I mentioned I'll read it. Is the $1,200 for the web-enabled unit and data the cost for 1 year of data service? And I'm glad you asked for the clarification on that. Yeah, that price includes the first year of data service. Then the reoccurring charge is typically $199 or $299, depending upon the level of service plan that you subscribe to. And you can change it year to year too, depending upon if your needs change or not. Now here's just kind of a general question. It's something good to be aware of. Is there currently a wait time to get the modules and equipment, or are most units readily available to ship? You want to address that?
Yeah, with the cellular stations, so the RX stations, the ones that can have the HoboNet capabilities and also those plugged in sensors, there's currently about a 3 to 4 week lead time on those.
Next question, can the wireless Bluetooth temperature loggers read through the walls of freezers? And I'm going to take this one too because I have a little bit of firsthand experience there. It depends on how thick the metal is. Bluetooth doesn't like going through metal, but it can go through metal, especially if you're close by. And I have actually deployed our Hobo loggers with the Bluetooth in like my own freezer to check the temperature when the power was out to make sure that it didn't get too warm in there. And for this is just obviously a home freezer, but it had no trouble transmitting the Bluetooth through the freezer to so I could read it out without having to open up the freezer. So it might require a little bit of experimentation. If you've got really thick-walled freezers, it's probably not going to go through those. But if you've got moderate wall thickness, you probably can go through it. So, other questions? I think we've covered. Oh, I should note, I see a couple questions in here about our water loggers, and I think we'll follow up with you on those questions independently, like some of the details of using our conductivity data assistance. We do have other webinars that cover that, so you can refer to those, but we'll make sure to have somebody follow up with you individually on those, just because those are kind of a whole different ecosystem of using the loggers. I mean, it's a lot of the same software, but it's really off topic for this webinar. So I didn't want to make you think that I didn't read your question, but I do want to defer that. And here's a question. Just who can we contact at Onset for help with the design of our system? And well, I'll point you to Ellie. She's especially in this field, she's a great person to reach out to, and she's included her email address here. So feel, especially in the fields that she mentioned of environmental research and agriculture research and agriculture in general. She's glad to help you, but also feel free to reach out to us by email at any time. Call or email us. All the contact information is in our website. I'm going to put in a plug for our website because it is a really valuable website full of a lot of resources, and a lot of times you can get your questions answered there, but you always feel free to call us or contact us by email, and all that's on the website. Let's see. I think, what else? Oh, here's, I'm sorry, I'm just having to read some of these live. Oh, here's a question. Is it possible to turn off the Bluetooth of the sensors to reduce signal interference? And yeah, let me address that one again. It's more the loggers that I work with. Is the standalone Bluetooth loggers. They have a mode where you just you can turn off the Bluetooth communications when during logging, and then you just have to push a button on the logger to turn on the Bluetooth communications when you want to connect to it and offload the data. But that will allow you to turn off the Bluetooth for most of the deployment, saves some battery, and it also avoids the chance that it could interfere with other equipment in the area. But the Bluetooth is pretty low power, and we do test our loggers so that Bluetooth isn't going to interfere with other equipment in the area. So it's usually not an issue. Let's see. Okay, good. We're getting some more questions. This question. Okay, this is thank you. Somebody just pointed out that the in Ellie's email address on this slide that there's a hidden underscore between Ellie and Snyder in her email address. So make sure to type in that underscore so that if you're trying to reach out to her. So thanks for that, David. And I got a question here about mixing sensors, water and indoor, on the same recording logging home station. Is yeah, I think I understand the question. So yeah, you can mix the sensors. They can be outside, inside, water sensors all feeding into the same central RX station with the wireless. So if that doesn't answer your question, Stephen, feel free to follow up. I see also that we're just about through our time here. I think we allowed, 45 minutes? So thanks for those of you that hung in there. So let me, at this point, I think we've gone through most of your questions. And again, for some of the detailed questions, we're going to follow up with you individually. So let me turn it back over to Ellie to close us out.
Thanks, Paul, and thanks for your questions. As Paul mentioned, we'll follow up with any unanswered questions, and also you'll be queued in to some of our Onset emails and informed about different events, webinars coming up based on your product application that you specified when you signed up. So if you did include other questions, we will certainly follow up with you. And thanks again for attending.